So one thing I want to show you that I think will really help you to understand how these streams work and how this decorator pattern works in Java is how to actually implement this yourself. And we can do this really simply, and I think by seeing this, it really helped me when I had done this the first time to be able to understand how these streams are actually working and why am I passing in something into the constructor. Why can't I just read from this file and not have to do this file writer and print writer and remember all of these different types of streams? Why can't I just read from this file? And the answer to that is because we need to be able to combine different attributes. And it's really hard to see between this file reader and this print writer what the attributes are. Or the same thing on the reading side between this file reader and buffered reader. But if we were to create our own writer or reader, we made it so that it capitalized everything that it was going to read, for instance, then I think that makes it a little bit more clear here. So what we're going to do here is we're going to create our own file reader, or we're going to create our own reader that's going to take a reader and it's going to capitalize everything that it reads. And we're going to plug this right into the chain. Just like we had wrapped our file reader in a buffered reader, we're going to wrap that buffered reader inside of our capitalization reader. So let's go ahead and declare this out and see how we want this to look, and then we'll implement this. So I'm going to create a capitalization reader, and we'll call this CapReader. And we haven't created this class yet. It doesn't exist. We're going to implement this class in a minute here. And we're going to make it so that this CapReader will basically wrap this buffered reader. In fact, it'll work with any type of reader. So we're going to pass in BReader here. And then instead of getting our line from BReader, we're going to get it from CapReader. And then instead of trying to close our checking for BReader, we're going to check CapReader, and then we are going to close our CapReader. So now let's go ahead and create this class. So I'm going to do create class here. And inside create class here, I'm going to make the superclass of this reader. And I can click browse here to see that I want to use this reader, this Java IO reader. And I'll click finish. And you can see it's automatically tried to implement some of these methods for me, or override these methods. We're extending reader here. Now we could do this at a very basic level, but we'd have to implement this read method that takes in a character array as a buffer, and then an offset, and then a length, and that's a little bit more complicated than I want to get into here. So let's change this. Instead of extending reader, let's go ahead and just extend buffered reader, because it extends reader. So that should work. That is a type of reader, since we can just extend buffered reader instead. So we'll go ahead and add this constructor that's required here. So we're going to take in a reader in our constructor, and then we're just going to pass it to our parent class. Our buffered reader, that is our parent, will pass in whatever reader we get. But we're not doing anything special here. So let's go ahead and use this refactoring here. We're going to right click on capitalization reader. We're going to click source, and we're going to choose override/implement methods. And this is just a shortcut in Eclipse to be able to override methods very easily and see what you can override. So we're going to override some methods on buffered reader. We could have overridden some on reader, you can see here, but we want to override this read line, because this is the one that we really care about here. So for read line here, instead of just returning whatever is read from our parent class, we're going to store that in a variable. So let's go ahead and do this. Let's create a string called line, and we're going to call super.readLine, which is going to call readLine on our parent, which is our buffered reader. And then we're going to check to see if we got something. If line does not equal null, then we're just going to return our line to uppercase. Otherwise, we're just going to return null. So if we got null from the parent reader, then we'll just return null. But if we got, we're going to uppercase. But if we got something, we're going to uppercase it, and we're going to return that. And so what this is going to do is it's going to use our parent. It's going to use a buffered reader internally to do all the reading, so we don't have to re-implement all this reading logic. We're just adding something to the chain. So we are basically inserting ourselves into this pipeline and saying, okay, once we read the data, we're going to manipulate this data and then pass it back. And we're going to use the buffered reader here that we're extending to read this line. So let's look at this in the code that's using it, and it'll make a little bit more sense here. So now our code that's using it, we had created our capitalization reader. And our capitalization reader, we created a new one here, and we passed in our buffered reader, which had passed in our reader. So we've wrapped this 3 layers deep. We have our file reader that's able to read from a file. We've added this buffering layer over it that allows us to buffer the text from this file so we can read it in a stream. Instead of reading it 1 byte at a time, we're able to read the entire line. And then we've wrapped that in this ability to capitalize everything that comes out of the stream. So, and these are plug and play compatible. We could mix these up. We could create a lowercase reader, and we could insert them at different layers, or we could use a compression reader that's able to read something that's compressed. So we could mix and match these together. This is kind of the idea here, is that we can keep on chaining them, and none of these need to know what the other ones are doing. It's going to apply these operations in this specific order, because remember, our capitalization reader, it's relying on a buffered reader. So it's going to call the buffered reader in order to read, and then that buffered reader is going to call the file reader in order to read. So then we're going to end up reading from this file, and every time we're calling ReadLine here, if we look at our capitalization reader, how's this implemented? Well, we're overriding this ReadLine, and instead of just reading the line, it's going to go ahead and read the line, but if the line's not null, it's going to uppercase the line and then return that result. So let's go into our hello world, and let's go ahead and run this and see what happens here. You can see there's no output to the console, but if we go into our temp directory here, you can see our output page now has everything capitalized. And if you remember, our input, our test.txt, does not. So we can see that by applying this reader, we're able to make it so that everything got capitalized. So you can think about a lot of different ways you could utilize this. You could create a reverse reader that's able to read things in reverse, some kind of proprietary compression or encryption that you're doing, all kinds of ways that you'd be able to extend this. And if you think about, let's say you wanted to write an encryption reader that was able to encrypt using some kind of encryption algorithm, if you didn't have this capability in Java, as hard as it is to have to do this kind of syntax where you wrap things together, if you didn't have that ability, if you wanted to write an encryption reader, you'd have to implement low-level I/O yourself. You'd have to re-implement all of this. Whereas now all you would have to do is just like we did with this capitalization reader, and do your encryption here, or your decryption. You'd create a reader and a writer, and then you'd have all that functionality just implementing 1 or 2 methods. So the last thing I want to show you here are some simple examples of doing some basic file manipulation. A lot of times in Java, you're going to want to be able to do some things like create a file, delete a file, or move a file. And it is not always straightforward to figure out how to do that, especially things have changed a little bit since Java 7. And I'm going to show you some ways to do this in Java 7 since Java 7 is now released. And it has kind of improved the API a little bit. I don't know if it's really made it a lot simpler, but I'm going to show you how to do this in the Java 7 API. And the basic root of these kind of file operations is this class called path here. And the way that you can create a path, this is very similar to a lot of the functionality I'd seen in C# and .NET, is to use this paths.get. And so paths.get, it kind of gives you the ability to pass in a directory or a string that represents either directory or file, and it'll represent that as a path. And all of these file manipulation operations work on a path. So I've got some code I've already prepared here to save us a little bit of time, since this is some pretty basic code here. And what I want to show you is how to use this and how to use path. So I've created this paths.get for the c/temp/newfile.txt, and this is the file that we're going to use here. And the first thing we're going to look at is how to create a file. So another shortcut for Eclipse here, as you can see, I've got this code commented out, if you highlight code that's coming out and you hit Control-Shift-C, it'll uncomment it. And if you hit Control-Shift-C again, it'll comment it. Really useful for coming out a block of code quickly. So to create a file, all that we need to do is we can either do it this way that I have here, or what we've already seen before. If you remember in our printer.java, we created some files here. When we did this output page, we used this print writer and it automatically created this file for us. But let's say you just want to create a blank file, basically the equivalent of a touch in Unix. What you can do is you can call files.createFile and you pass in a path. And we had created our path here. So that's the basic way. You just want to create a file in Java. Now, with this new Java 7 API, you'll create a path to your file, and then you'll call files.createPath. And of course, you need to catch an IO exception here. So let's go ahead and run this and see what happens here. You can see that it should have created in our temp directory. And I'll bring up our temp directory. You can see here that we have this new file.txt. There's nothing in it. So let's move on to the next example here. I'll comment this back out, and then let's look at how to delete a file. So to delete a file, it's very similar. Again, here, there's two methods that you can call. You can either call files.delete if exists or files.delete. Delete if exists won't throw an exception if the file doesn't exist, which is kind of useful if you just want to use this as a cleanup in case a file exists. Delete it instead of having to check, does the file exist? You can do this all in one call now, which is kind of nice. So again, it just takes a path. Let's go ahead and run this and see delete this file. And you can see that it's no longer in this temp directory. And then the last one that we're going to look at here is moving a file. And you could copy a file almost the exact same way. I'm just choosing move here, but you can basically do a copy by doing files.copy. And for copy or move, what you do is you just pass in the path, and then you have to create another path for the destination. So source and destination. Pretty basic stuff here, but I want to show you it just so you know how to do this. You don't have to go hunting around for how to do these basic file operations in Java, especially since there's two different APIs now, and this is the newer one that you should be using for Java 7. So I'll go ahead and uncomment this creating the file, and then we'll move the file and make sure that works together. So we'll go ahead and run this whole thing. And then when we look in our temp directory, you can see now we have this moved file.txt. So that's it. That's the basic operations here. With the Java 7 API, there's also a few other things you can do that have been added to be able to more easily handle directories, managing directories. You can do a lot of these same operations against directories instead of files now, and this path class is able to let you combine paths together and things like that. A lot of the functionality that you would need on file systems that really didn't exist before in Java. But here's the basics: creating, deleting, and moving. So let's go over what we covered in this module. The first thing that we did is we talked about the basic I/O concepts. We talked about the idea of streams in Java I/O and how everything in Java I/O is based off of this concept of streams that kind of act like pipes to carry your data. Then we talked a little bit about the decorator pattern, how everything is implemented using this decorator pattern, which basically allows you to use streams to wrap each other and kind of combine the attributes of different types of streams together instead of having to have specialized ones for each particular combination of things that you'd like to do. And then finally we took a look at the class hierarchy of the streams in Java, and we saw how there's character-oriented streams and byte or binary data-oriented streams. Then we went through and we actually got into the code, and I showed you how to actually read from a file using a basic file stream in Java. We used a file reader to be able to read from a file. And then we went ahead and we did the opposite, and we used a file writer to be able to write to a file. Then we went ahead and we actually created our own stream reader. We saw how to create a capitalizer stream reader to be able to capitalize input that's coming in. And this kind of gave us an understanding of how this decorator pattern works in Java to make the I/O simpler. We saw that we could use this capitalizer to wrap another stream and to basically not have to even know what the other stream was doing. And so we could add some attribute to our stream chain by making all of the data that we read in capitalized. And then finally, we looked at some basic file manipulation. I showed you how to do things like creating new files, deleting files, and moving files around in Java. So that's it for file I/O in Java, or I/O in general in Java. We kind of focused on files, but these same concepts would apply to network I/O or any other kind of I/O operation that you would use in Java. File is probably just the most common type. And don't worry if you don't get this right away. There's a lot here, and it is not the simplest thing in Java to understand and memorize. But I think by having a good understanding of the concepts here and how the decorator pattern is being used here, you'll be able to quickly figure out what you need to look up, perhaps in the Java reference documentation, in order to figure out how to do this. Or you can always go back to this course to look up how to do file reading or file writing in Java.